Alright, welcome back. This is the final homework in thermodynamics. This is a new homework solutions. This is for homework 9, which is other vapor-liquid equilibrium concepts. And so this first problem, which is out of Koretsky 8.61, is the phi-phi algorithm. Sometimes it's called the equation of state method. Okay, but like any other vapor-liquid equilibrium problem, it really boils down to what do I know, what do I don't know, what do I have values for, and equations that I need. Now in this case, I know x1 t, and I'm trying to find the vapor composition and the pressures. This is a bubble pressure problem. Now again, I could use the phi gamma method, but in this case I have methane and then pentane. And, you know, an equation of state might be more appropriate in this case. Okay. So I start with my equations. So I have yi phi I hat in the vapor equals xi phi I hat in the liquid. Okay. And so what do I know? I know, let's see here, xi, and I know t. I don't know p and yi. Okay. Which means I also don't know all my phis, whether it's in the liquid or the vapor, because I don't know pressure. I guess I know pi sat. Doesn't plays a role, but not a direct role. Now, where does it play a role? Well, we want to treat this problem first like a Raoult's-Law for kids problem, which says, because I know yi, I also know that summation of yi should equal 1, but it doesn't. Okay. Now, I'm going to first treat this like a Raoult's-Law for kids problem. Now, I'm not going to go through all the steps, but essentially, you know, yip is equal to xi pi sat, and summation of yi still equal to 1. This will allow me to get an initial pressure and an initial set of yi's. Okay, you know, because essentially p is going to equal the summation of xi pi sat, where the pi sats can come from Antoine's, and then of course yi is going to equal xi pi sat over this gas pressure. Okay, but those are just guesses. They could come from really anywhere. Okay, we could use yi equals xi in this case. Doesn't really matter in terms of pressure. Well, that one sounds good. In any case, so I have a yi, I have a pressure. Okay, now I can get my my a and b parameters. Now I didn't really need pressure before to get a and b for the pure. Okay, so I get my AIs and BIs normally, okay. You know, and I just write down the equations for those, what have you. Okay. So I have AI, I have BI. Now I need my A mix, which is the summation of, we'll use Z so that it's independent of phase. So ZI, ZJ, AIJ. Now where AIJ is equal to the square root of AI times AJ. Okay. And so when I write this out for a two-component mixture, it becomes Z1 squared A11 plus 2Z1 Z2 A12 plus Z2 A22. That's squared. Okay. Now, so this A11, this A12, and this A22 do not change ever. What does change is my Z's, based on, you know, the system and the known and all this other good stuff. But we'll get to there in a sec. So B mix is just equal to summation of ZI BI. Okay, so again, the BI's in this case don't change, the Z's do. So what do you want to mean by change? Well, first off, I'm going to have an A mix of the liquid, which is going to equal the summation of xi, xj, aij. A vapor of the mixture is going to be equal to the summation of yi, yj, aij. And same things for the B liquid mixture. It's going to equal the summation of xi, bi. And the B vapor mixture is going to equal the summation of yi, bi. Okay. Now I'm sitting on the floor because, well, my legs broke. So, in any case, so I have my AL mix, my AB mix, my BL mix, my BV mix. Okay. Now the equation I want to refer to is on, let's see here, it's in chapter 7, under vapor fugacity. It is on page, almost there. It is on page 408. So I'm looking at species 1 in a binary mixture for van der Waals. Okay, so it says I need B1. Okay, B1 I'll just calculate normally. It says I need B or B mix. Well, my B mix depends upon my phase. So the B1 is not going to change, but my B mix is going to change. Okay, my V. Alright, well I need a V. We'll get to V in a sec. Okay, I need a P. Well, I have a guess for P. Okay, so I got a P, I got an R, I got a T. And then I need A1 and A1 too. Okay, I've already got those. All right, so really the only thing I'm missing for the fugacity coefficients up here, because I have the A for the liquid, I have the A for the vapor, I have the B for the liquid, I have the B for the vapor. What I'm missing is the volume. Okay, so I'm going to raise some of this stuff, okay? Okay. And so, if I look at van der Waals, it says P is equal to RT over V minus B mix minus A over B, A mix over V squared. Now, the pressure and the temperature are going to be the same, but because this is a cubic, I can have more than one root. In fact, I can have 3 roots. One is corresponding to the liquid, one is corresponding to the vapor. The third one, the one that's in the middle, is garbage, but we're going to ignore that one. Okay. But what I do is I solve for this guy with my different B's and my different A's. Okay. So this is going to give me, so my A of liquid and my B of liquid is going to give me a V of liquid. And my A of vapor and a B of vapor is going to give me a V of vapor. Okay. And I can get that through solver, through a code, through a lot of different things. Okay. So now I have a volume of a liquid and a volume of vapor. This allows me to get phi, and these allow me to get phi hat of liquid, and these let me get phi hat of vapor. Okay, so now I have a value for that, I have a value for that, I know that, and I have a value for that. Okay. So I ask myself my 3 questions. What do I know, what do I don't know, and what do I have value for? Now I have value for everything. Okay. So, and I know xi, I ask myself, what did I get first? Okay. Now technically I got P first. Okay, but I don't want to get P quite yet. Okay, I'd rather get yi first. Think of them as I got them simultaneously. And so if I got yi first, well, and the reason why I want to get yi is because I have an equation that's directly related to yi, this thing right here. I can say that yi is equal to xi phi hat liquid over phi hat vapor. Okay, because I have a value for vapor, and I have a value for liquid, and I have xi's, I just know my xi's. Okay, so I have all 3 of those. I can get new yi's. Now, I'm going to have this for 2 different components. Okay, so I'm really going to have an AL, a BL, a VL. Okay. Now the VL is the VL. Okay, that's the volume of the liquid with all this stuff going on. The only thing that's going to change for component 1 and component 2 is the stuff that says component 1, component 2. So if I look at the equation, for example, there's a B1 over V minus B mix. This B mix and this V are going to be the same for the liquid no matter what. The only thing that's going to be different is this B1 between component 1 and component 2. Same thing for the phi vapor. Okay. And so I'm going to have a Y1 and a Y2. And they are not going to equal 1 when I sum them up. They're just not. Okay. And we don't want to force them to equal 1, and the reason we don't want to force them to equal 1, because that's actually our decision criteria. When they are equal to 1, we're done. Okay. Because what we're going to do is we're going to get a Y1, we're going to get a Y2, we're going to check to see if they're equal to 1, and if they are not, we're going to make this a weighting factor. And we're going to use that weighting factor to fudge our pressure. So our old pressure times our weighting factor, which is either going to be greater than 1 or less than 1, is going to, dictate our new. Now it's going to be close to 1. It might be 1.01 or it might be 0.99, but it's going to be close, and that's enough to fudge P. Okay. And so now I've got a Yi, I've got P's. Okay. What did I get next? That's right. I got B vapor and A vapor. Now I don't need I don't need to recalculate A liquid because the X's don't change and the AIJs don't change. Same thing with the B liquid. The only thing that is going to quote-unquote change for the liquid is the phi. Now what would change the phi? See, A doesn't change, and B doesn't change, and liquid volume, would liquid volume change? Liquid volume would change because my pressure has changed. Okay. So I do have a new liquid volume because I have a new pressure. Okay. I already raised Van der Waals, but if I have a new pressure, that means I have to have a new liquid volume. Okay. Which is going to make a new phi liquid. Okay. For each component. And same thing for phi vapor. Okay, so I'm going to use this new pressure to get my new volumes, okay, which will get me new phis, and my new phis will get me new y's, and my new y's will get me a summation, and I'll keep going in the circle until this actually does equal 1. Okay, so either that's going to equal 1 or my pressure's not going to change. Okay, now I'm not going to go through all the math. The math can get kind of tedious. I'll leave that up to you, but that is the procedure of how I would proceed.